Yeah, let us start today's session. The last class where we left, where we stopped exactly, we stopped at working out evapotranspiration, right? Infiltration completed. Right. Next, let us start the runoff. The very purpose of working out, the last class we discussed about infiltration. Infiltration we can work out by two methods. One is Harton's approach. The second one is infiltration indices. So using that, we can find out rate of infiltration and as well as total infiltration. Harton approach, that equation you have to remember. FCT is equal to this infiltration you can find out by integrating equation integral 0 to t FCT into dt. That FCT equation if you integrate FC plus FC naught minus FC into e power minus kt into dt, then you will get total infiltration in time t. Similarly, infiltration indices, by using pi index you can find out runoff infiltration. So pi index is equal to P minus R by T. Infiltration is equal to, it is pi index into T. This will give infiltration. Pi index represent average rate of infiltration. Average rate of infiltration means infiltration in a given time. Infiltration in a given time into time will give infiltration. Time get cancelled, left with infiltration. So this is how we can work out. Anyway, that's what we discussed. Let us see today how to work out runoff component. Okay, let us straight away jump into runoff estimation. So before we talk about runoff, we suppose know the terminology related to runoff. So we got so much wide term, so much different kind of terminology we use for runoff. Runoff, also known as rainfall excess. It is also known as excess rainfall. It is also known as effective rainfall. Right? Runoff is that portion of rain which ultimately joins the water body. The portion of rain which ultimately joins the water body is known as runoff. Runoff is that portion of rain which ultimately joins water body. So mostly you will get questions from runoff only. Ultimately joins water body. Infiltration and runoff. These two topics are very, very important. That portion of rain which ultimately joins water bodies such as rivers, lakes, ponds, reservoirs, they're all water bodies, isn't it? They collect runoff from a catchment. So runoff is that part of rainwater which is ultimately drained into a water body is called runoff. So this runoff is equal to, normally we work out by different methods are there. Runoff is the only quantity which cannot be measured, which can only be estimated by mathematical approach. So to work towards working out runoff only, this hydrology subject is required. So runoff is the only thing which cannot be measured by any device. You can measure precipitation by rain gauges. You can measure evaporation by evaporimeters. You can measure transpiration by phytometer. You can measure evapotranspiration by lysimeter. You can measure infiltration by infiltrometers. But there is no device to measure runoff. Okay? So it is the only quantity that we have to estimate. We have to, by analyzing, by performing a hydrological analysis in a catchment, we try to find out runoff component. So there are different types of runoff, also known as effective rainfall or net rainfall. Effective rainfall, net rainfall, or excess rainfall, or rainfall excess. All are one and same. All are synonyms for runoff. Okay? Excess rainfall or rainfall excess. Different people, to confuse you, will ask you with different names. Rainfall excess. So there are so many ways this runoff joins the water body. It's called components of runoff. If you see how the water reaches the water body, based on the place from which it joins the water body, runoff is further categorized into three classes. One is called surface runoff, the other one is called subsurface runoff, the other portion of runoff is called groundwater. One is surface runoff, Second one is subsurface runoff. Some people also call it as interflow. And third one is called groundwater runoff. You see the catchment from the place from which it joins. Suppose if you draw a catchment, this is a catchment, assume. This catchment ultimately drains water into a source. This is a source. Source could be a river, source could be a lake, source could be a reservoir, whatever it may be. So rain occur in a catchment. So this rainfall which occur in a catchment, after meeting all catchment losses, what is the catchment losses? Infiltration loss. So instant loss is infiltration only. After infiltration, right, remaining portion of runoff that flow above the ground and joins this water body. The runoff which flow above the ground and joins the water body is called surface runoff. This portion is called surface runoff. So some portion of water infiltrated, it straight away move laterally in the catchment and ultimately joins the water body from the top layers of the geological strata. That is called subsurface runoff or interflow. Simply you can call it as interflow. So the infiltrated water which laterally move from the top layers of the geological strata and ultimately joins the water body is called interflow. This is called interflow. Okay? And remaining portion of runoff which flow deep inside the ground joins the groundwater table. That groundwater also, it doesn't remain at one place, it keep on moving. Ultimately this groundwater also delivered into water course only. This portion is called groundwater runoff. So wherever water is there in a catchment, ultimately catchment, right, drain that water into a water body. Catchment is generously drain water into a water body. It doesn't retain any water. So sooner or later, all the water which is collected in a catchment, that is delivered into a source. So source carry that water from one place to another place. That is how hydrological cycle happens. Assume that this is a water body, a river otherwise. So this is a catchment. Catchment to river, how water flows? Different ways it flows into river. Some portion of runoff joins the water body from the surface. From some portion of runoff joins the water body from subsurface of the catchment. Some portion of runoff joins the water body from deep inside the catchment, deep inside the ground from a catchment. So depending upon that, it is known by different names, whatever it may be. So ultimately the water joins the water body or not, that is important. Based on the time delay in joining the water body, hydroscopic water, hydrographic water. This is a term connected to irrigation engineering. Irrigation engineering, we use those terms. Hydroscopic water has got a strong molecular force of attraction between soil grains and water. So that water you cannot remove by any means. Okay? That water is called hygroscopic water. So remaining water which flow by gravity within the ground, that water easily we can get that water. So we can easily draw that water. We can easily extract that water. Okay? Civil JE and AE, sir. What is hydroscopic? Hygroscopic. Okay? Water which is always remained in the soil is called hygroscopic water. Understood? Water which can remain in the soil, which can also be extracted, both of them together known as hydrographic water. Okay? Anyway, that is all different issue. So based on the time delay in joining the water bodies, this runoff is classified into two categories. Based on time delay, based on the time taken by the water to join water bodies, runoff is further classified into two categories. One is direct runoff. So other one is base flow. So direct runoff is that portion of runoff which fast drained into catchment, fast drained into a source from a catchment. So without any much time delay, the runoff joining the water body is called direct runoff. So as soon as it accumulates in a catchment, immediately, instantly, catchment deliver that runoff into water body. That part of runoff is called direct runoff. So runoff joins the water body without much time delay. Runoff joining the water body without any time delay. See now sometimes what happens, so we start class 8:30 means sharp 8:30 only will start. Sometimes due to some obvious reason class start late. Announced at 8:30, I may start at 8:40, I may start at 9 o'clock. So I keep on, students keep on waiting for me. So that is bad for it because of internet problem, because of some problem. Okay, virgin flow I will discuss one by one. First listen the class. You keep on asking questions means I can deviate again. You are obstructing my flow. So you can't collect the runoff properly then. Okay, I'll talk about all those things. Okay, runoff joins the water body without much time delay. That is fast delivered runoff is called direct runoff. Fast delivered runoff from a catchment is called direct runoff. So this includes, direct runoff includes surface runoff and prompt interflow. So surface runoff, this interflow further classified into two categories, prompt interflow, delayed interflow. So direct runoff includes two things. Direct runoff includes one, surface runoff and two, prompt interflow and channel precipitation. Precipitation that occurs straight away in the water body, that immediately instantly join the water body. That's called channel precipitation. All these three things put together, it is called direct runoff. Among these three, channel precipitation is so small compared to surface runoff and prompt interflow. Generally direct runoff means it is surface runoff and prompt interflow. And base flow means the delayed runoff. The delayed runoff from a catchment is called base flow. So time taken, it takes its own time in joining the water body. So delayed runoff from catchment is called base flow. So it takes months together in joining the water body. Instantly, today it rains, the rain water which get into ground, to get out of that rain water from the ground, it takes months together, sometimes years together also. So that part of runoff is called base flow, known as base flow. Okay, so base flow takes its own time in joining the water body. Base flow takes time to join the water body. Prompt interflow also called seepage. Okay, whatever you know, you write to type there. Then why you are attending class then, if you know everything? Base flow takes its own time. Base flow takes its own time in joining the water bodies. It is not delivered quickly. It is delivered late. Okay? So base flow includes two things. One is delayed interflow. Second one is groundwater. Delayed interflow and groundwater together known as base flow. So this much idea should be there with you. Delayed interflow and groundwater together known as base flow. Okay, this much idea is there. More than sufficient. You are asking virgin flow, right? Ashish. Okay, I'll explain you virgin flow. Virgin flow is that portion of runoff which is not affected by the works of men in the catchment. So nowadays what is happening? We are carrying out so much construction work in a catchment. In a catchment only you construct a building. In a catchment only you construct a check dam. In such case what happens? Water will be stopped in the catchment. Catchment is not freely draining the water. When catchment stop water within a catchment, right? Then we get a poor response from a catchment, isn't it? So therefore, the virgin flow is that portion of runoff which is not affected by the works of men in a catchment. That is, there is no check dam in a catchment, there is no building constructed in a catchment. Catchment is freely draining water is called virgin flow. So virgin flow means runoff not affected by the works of men in a catchment. not affected by the works of men in a catchment. So nowadays what is happening to recharge the ground, what we are doing is we are constructing so many check dams in a catchment. If you construct a check dam in a catchment, what happens? Water is stopped there, water is forcefully pushed into ground. That's called rainwater harvesting. It's happening now everywhere. So in such case, that is not a virgin flow. So catchment which freely drain water without affected by such works within a catchment is called virgin flow. Works of men in a catchment is known as virgin flow. Understood now, Ashish? Clear now? Okay. Now let us see how this runoff is estimated. So methods to estimate runoff. Our job is how to work out runoff component, because runoff is the only component which cannot be measured by any kind of device. Methods to estimate runoff or runoff estimating methods. So there are so many methods are there. One method is very popular, so we talk about that method right in detail in this course. This course is meant for that method only. To teach you that method only, this course has designed. Okay, hydrology course is meant for that only. Because hydrology means we are working out runoff component only. Okay. Let us see first method. So let me first list out all the methods. We'll discuss one by one. The first method is using rainfall runoff relation. If rainfall data or runoff data is available with you, by establishing the relation between rainfall and runoff. Rainfall is a measurable quantity, measurable parameter. So know the rainfall, find the runoff. Okay. Rainfall runoff relation. How relations are established between the parameters or among the parameters? By regression analysis. Generally, for 1 mark, 2 marks regression kind of questions, no way you will get in the exam. Therefore, this method is ruled out. By regression analysis, regression curve fitting we studied in mathematics. So by using regression analysis, the relation between rainfall and runoff is estimated. Relation between rainfall and runoff is established. So for this, what do you require? Data is required. If rainfall data is available, runoff data is available, using that data by regression, by regressing the data, you can establish the relation. For example, I can give you example. So runoff is equal to, right, A times rainfall plus B, AP plus B, like that. A and B are called regression constants. So linear regression. Similarly, non-linear regression. Relation could be non-linear also. This is called linear regression. Just giving one example. For a given data, there may be a relation, linear relation or non-linear relation that you have to establish. Or otherwise, it is A square P plus BP plus C. This way also you can find. Or AP square, AP square plus BP plus C. Like that also. This is called non-linear regression. Example I am giving. Not exactly same way. One equation you will get between rainfall and runoff. So runoff is a function of rainfall, isn't it? No rainfall, no runoff. Very simple. Non-linear regression it is called. Okay. Example I am saying. For regression, curve fitting and all impossible for 1 mark, 2 marks question. Therefore, this method is ruled out for you. So this A and B, A, B, C are called regression constants. For a given data, these constants will get. So this is one method available to work out rainfall, runoff component. No rainfall. Rainfall is a measurable quantity. So find the runoff using the equation. That's one method. We also have got so many number of empirical procedures. Empirical procedures also available. These empirical procedures developed by British people when they were ruling our country. So British engineers, they have developed so many number of empirical procedures. Even today we are using them. They are so good. But the problem with empirical procedures is procedure developed for one catchment or one region, that is true for that catchment and true for that region only. Elsewhere you cannot use it. So there is no universal, application of that procedure. So they are place specific. They are place specific, therefore you cannot use elsewhere. There's a problem with them. So you have to remember. So different catchment, different procedures are given by British engineers. For Indian catchment, they have done extensive work in Indian catchments. They have developed some procedures. Even today, in practice, many people use those procedures. They are so simple and so easy. For example, we have got Binnis percentages. These Binnis percentages, they are widely applicable for catchments in Madhya Pradesh and Vidarbha region. Vidarbha means Nagpur area of Maharashtra. The Nagpur part of Maharashtra is called Vidarbha. Vidarbha and Madhya Pradesh, they are bordering with each other. In that region, British people have developed this procedure. Binnis percentage is true only for that catchments in Madhya Pradesh, catchments in Nagpur region. So there Binni has developed straight away percentage table is given to him. So know the rainfall P. So portion of percentage of rainfall converted into runoff, Binnis percentage. So this is Binnis percentages. So rainfall, example I am giving. 1 mm rainfall occur. For 1 mm rainfall occur, maybe 20% of rainfall is converted into runoff. 2 mm rainfall occur, maybe 30%. Example I am giving. Like that, different magnitudes of rainfall, different percentages have developed by Binni with his own work for the catchments which are there in Madhya Pradesh and Vidarbha region. So, but this procedure is true only for that area. Elsewhere you cannot use them. Similarly, we also have got Barlow's tables. These Barlow's tables are widely used in Uttar Pradesh region. Barlow's tables. UP, catchments in UP, you can use them. Barlow has straight away developed a table. You know rainfall, find runoff. So 1 mm rain, runoff may be 0.2 mm. 2 mm rain, runoff may be some 0.3 mm. Like that, different magnitudes of rainfall, runoff components are straight away given to you. So straight away you can find out. Even no need to multiply with percentages. At least Binnis percentage you have to multiply. Percentage of rainfall is equal to runoff. Percentage of rainfall is equal to runoff. Like this, at least you have to multiply with the P. Here no need to multiply. Straight away read the values. Barlow's tables. Similarly, Strange tables. So like that, so many empirical procedures are available. Strange tables are true for Maharashtra and Karnataka region. Right? That North Maharashtra and Karnataka, they are bordering with each other. West, that is North Karnataka and South Maharashtra are Konkan region. In that area, you can apply this method. Goa and other places. Strange tables you can use. Like that, every region there is one procedure. So this kind of questions also competitive exams, no way you can ignore them. No need to remember them, no need to know anything about them. Then third method is watershed simulation. Watershed simulation is something like watershed is treated as a system, right? The system receives certain inputs and system produces some output. That output component is in the form of runoff. So input component is rainfall minus catchment losses. So what are the catchment losses? Rainfall minus evaporation minus transpiration minus evapotranspiration minus infiltration minus other losses if you take into catchment, then you will get runoff component. But these many parameters in a catchment you have to work out. You could manage to work out all these parameters. This is the best method and more accurate method also for a given catchment. Because all these components can be measurable. Rainfall you can measure, evaporation you can measure, transpiration you can measure, evapotranspiration you can measure, infiltration you can measure. Therefore, straight away you can arrive at runoff. Okay? But these many parameters are required. Then fourth method is Horton's curve. Horton's infiltration capacity curve you can use. Horton's infiltration capacity curve already we discussed. Horton's curve can also be used for runoff by superimposing Horton's infiltration capacity curve over rainfall hydrograph along with the infiltration. You can also work out runoff component. If you superimpose this, the area above Horton's curve, area of hydrograph above Horton's curve represent runoff only. Measure that, you will get it. Then using infiltration indices also you can find out runoff. Using infiltration indices. Using Horton's curve, we can find out runoff. Using infiltration indices also, you can find out runoff component. So all these things already we discussed. So to teach you one method, particular method, this topic is designed using infiltration indices. Especially the pi index is popularly used to work out runoff component. Pi index is equal to P minus R by TE. From this you can find out runoff component. Or otherwise you can also use runoff is equal to, it is intensity of rainfall I minus pi into T, or sigma I minus pi into T. Runoff is equal to, right, I minus pi. I speak of intensity of rainfall. Intensity of rainfall into time will give total rainfall. Then average rate of infiltration into time will give infiltration. So rainfall minus infiltration is equal to what? Runoff only. So that is how we can work out the things. Already we saw some problems, numericals in infiltration topic related to them. So this is another method available. Then the last method is called hydrographs. So hydrographs are popularly used for what purpose? To estimate runoff from a catchment. Hydrographs. So to talk about these hydrographs, straight away we discuss about hydrographs, we'll get confusion. What purpose they are used? Why we are talking about hydrographs suddenly like this. So hydrograph is one of the methods available to work out runoff components. Runoff component from a catchment. So using hydrographs, runoff from a catchment is estimated. Using hydrograph and by performing hydrograph analysis. Runoff component from a catchment can be estimated. Accurately you can find out. Okay, let us now straight away. Hello Rahul, good evening, very good evening to all of you. Okay, let us straight away jump into hydrographs. Actually, hydrographs linked to runoff. Come on, what is hydrograph? All civil engineers, hydrographs are very popular for them. Okay, hydro means what? Water. Graph means what? Plot. It is a water plot. Nothing but a water plot. Then what exactly it represents? Hydrograph is a plot between discharge versus time. It is a discharge versus time plot. Hydrograph is a discharge versus time plot. What is a discharge? What is this discharge? Discharge versus time plot and how it is linked to runoff component. That's what you need to learn. I cleared entire E from you through deep learn, sir. Okay. Thank you, Rahul. Deep learn I taught very less, Rahul. Very less. Actually, that is 120 hours course. I completed in 50-60 hours. So I skipped so many numericals there. Deep learn. Anyway, content, okay, with content numericals you can solve no problem. Hydrograph is a discharge versus time plot. It is nothing but a discharge versus time plot. Okay, something like this. Discharge Q. Normally we express discharge in which unit system? Meter cube per second. Time T. T we express in which unit system? Normally in hours here. Discharge versus time plot, because what way it is linked to this topic, runoff component. That's what you need to learn. So if you see the hydrograph, its shape is something like this. Okay. So in this everything is there related to storm. Okay, let us see. So I am saying that it is a discharge versus time plot. What is a discharge? Stream discharge. Actually, whenever rain occur in a catchment, catchments are very big. Okay, this catchment finally converges into stream or a river or something like that. Where catchment terminates, there streams originate. This is a stream or river, whatever it may be. This one is a catchment. Where catchment terminates, stream originates. This is a catchment. In this catchment, runoff from different portion is collected and ultimately drained into a stream only, different parts. It will go there, different portions, and ultimately this whole runoff is delivered from catchment into stream. So when it is flowing within a catchment, it is called runoff. Once it is delivered out of the catchment, it is no more called runoff. That is, it is known as stream discharge. Once it is flowing in a catchment, then only we call it as a runoff. Once this all runoff is delivered from a catchment, it is a catchment. This whole thing is a catchment. All this runoff is delivered, direct runoff, subsurface runoff, prompt interflow, delayed interflow, base flow, all is delivered finally ultimately into stream. Once it is delivered, runoff is delivered. It is no more called runoff in a stream. It is called stream discharge. So therefore what we do? So it is difficult to measure runoff from a catchment because catchments are very big. For example, you see Krishna river has got a catchment of area 1,44,000 kilometers square. In 1,44,000 kilometers square, where you can measure runoff? 1,44,000 kilometers square area drain water into Krishna river. Then how we can measure discharge? 1,44,000 kilometers square area is there. Can you measure it? Impossible, that is. Practically not possible, isn't it? Is it possible to measure runoff from that large catchment? Possible, improbable, that is. Practically not possible. Therefore, what we do? Instead of measuring runoff in a catchment, we wait patiently at a point in a stream. This is called stream gauge station. We establish one stream gauge station at a point in a stream. So once runoff is delivered into stream in the form of discharge, when the discharge is passing into a stream, at one place where stream gauge station is there we measure how much amount of discharge passing through this station with respect to time. Because as soon as rain occur in a catchment, instantly, immediately all rainwater will not go and join the river. Slowly, after 1 hour, some portion of the catchment drain water. After few more hours, some more portion of the catchment start contributing runoff into stream. So after some time, maybe few more hours, right, entire catchment also start contributing runoff. So different times, different amounts of runoff catchment deliver into stream. Okay. Therefore, how exactly this is called catchment outlet. Where catchment outlet is there, that portion also called as stream inlet. Where stream inlet is there, where catchment terminates, there stream originates. Catchment outlet also called as stream inlet. Okay. So at a point in a stream, we measure discharge. We measure discharge here, somewhere here, because we are inefficient to measure runoff in a catchment. We don't have any procedure to measure runoff in a catchment. Therefore, indirectly we measure runoff resulting from a catchment by measuring stream discharge, because catchment is stop draining runoff, there is no discharge in the stream. Catchment is drain runoff into stream, then there is a discharge in the stream. Therefore, that part we measure. Is it clear now? Arjun Singh Panwar, I don't know. Your Unacademy people, I have to ask, I don't know. When I am going to teach in Plus platform or something like that. Let us see. I just started my innings in Unacademy platform. In future. Okay? That's how we measure. So by using this, we try to arrive at this runoff component. We try to find out this runoff. Using this hydrograph, we try to find out how much runoff catchment delivered. That what. So therefore, runoff also known as, this hydrograph also known as, it is a plot time distribution of runoff. So it is an output produced by the catchment for a given input rainfall. So hydrograph shows What it shows? Time distribution of the runoff. With respect to time, how runoff is delivered into stream. So it is something like a patient joins in ICU ward, ICU, right? The doctor is senseless, he is completely in coma state. So doctor keep on giving medication to him. Whether that patient, how he is responding to the medical treatment, how doctor knows. So there may be one graph will be there. There will be one display will be there, one screen will be there. In that continuously there is one graph. Keep on moving there. Whether patient is dead or alive, something like this, isn't it? Like this graph will be there. So whether patient is responding to the given treatment or not, he has to measure it continuously, because he is unable to communicate with the doctor. Therefore, his response to the medical treatment measured. What do you call it as? What do you call medical term? We call it as I forgotten the name. We call it as, any idea? It's called pulse rate also it shows. I forgotten the name anyway. How exactly this is important to a doctor? Exactly the hydrograph for an engineer. How catchment respond to the given rainfall? Hydrograph is the measure of response of a catchment for a given rainfall, whether it is properly responding to that rain or not. That's what we try to measure with the help of hydrograph. Okay. What do you call this? This one. I forgot the name. Okay, leave it. Time distribution of runoff. So it is a response of a catchment for a given rainfall. So we got different types of hydrographs. So the first type of hydrograph which everybody which badly we need to work out the response of the catchment is called storm hydrograph or flood hydrograph or total runoff hydrograph. We also call it as flood hydrograph. Flood occur where? In a river only. So flood discharge you measure, it's become flood hydrograph. Storm occur in a catchment. So for that storm we are measuring the response. Therefore it is also called storm hydrograph. And people also call it as total runoff hydrograph. In US people call it as total runoff hydrograph. So this is called SHZ, or shortcut we write SHZ stands for what? Storm hydrograph. FHZ, flood hydrograph, or total runoff hydrograph is TRH. Because it is resulting from a storm, people also call it as storm hydrograph. So storm in a catchment produce flood in a river. So because we are measuring flood discharge, it is also called flood hydrograph. So it contains both direct runoff and as well as base flow. People also call it as total runoff hydrograph. Okay, whatever name you use, no problem. This is the only real-time hydrograph. This is only the hydrograph which is physically by measuring stream discharge which is plotted. So this is only the real-time hydrograph. Remaining all hydrographs which we talk in this course, they are all mathematically derived. That is, by physically measuring stream discharge, hydrograph is obtained. By physically measuring stream discharge, hydrograph is plotted. Hydrograph is plotted. That's why it's called real-time hydrograph, without which it is impossible. to derive other kinds of hydrograph. Therefore, it plays an important role. So, if you see this hydrograph, there are so many number of components are there in this. You can find like this. So, this hydrographs which we get for a given storm, true for that storm only. For some other storm you can't apply. That means storm to storm, the storm hydrographs or flood hydrographs vary. For every storm you have to measure. Therefore, that storm information also we mention in the hydrograph. We are talking about which storm. So, storm information we measure, we give in the form of hydrograph. Hydrograph is a plot between intensity of rainfall versus time. So, what is the time? Duration of storm. Let us assume duration of storm could be D. D hours rain has occurred, right? The D hours storm produces this hydrograph. Therefore, we call it as D hour storm hydrograph or D hour flood hydrograph, something like that. So, I will take it as D. This gives something related to storm information. Then, if you see this hydrograph, there are so many number of parts are there in this. The very important parts being components. They are called components. So, O, A, B, C, D, E. That OA portion of this hydrograph is called approach segment. That means rain has commenced in a catchment, but yet to deliver discharge into a river. It is fast approaching the river. So, during that period, right, we get OA portion of hydrograph, approach segment. And AB portion of hydrograph is called rising limb. So, first drop of runoff, direct runoff, joins the water body at point A. From then onwards, more and more direct runoff joins the water body. Therefore, fast discharge changes, discharge increases. So, rising limb it is called, rising limb of hydrograph. And BD portion of hydrograph is called crest segment. And DE portion of hydrograph is called recession limb or falling limb. Because rain stops after some time, slowly runoff also stop contributing, catchment stop contributing runoff. Because once rain happens, catchment doesn't contribute runoff forever indefinitely. So, it will deliver that runoff for certain period of time. In that period of time only stream discharge varies. So, it is called recession limb, or some people call it as falling limb. Okay. Then that B and D points are called inflection points. B and D are known as inflection points where slope of the curve changes. Okay. And C portion is called peak point where peak discharge of the peak point, that is where peak discharge occur in a catchment, a river. This is Q max, maximum discharge, or QP, Q peak. QP, I will put QP, peak discharge. Okay? This is called QP. P coordinate of hydrograph otherwise. So, this A point is called point of rise. A is called point of rise. Point of rise means what? The first drop of runoff joins the water body at point A, point of rise. So, from then onwards it keep on rising only till it reaches to peak. Then E is called, or C point, or D point also called end of direct runoff point. Not direct runoff, end of surface runoff. Direct runoff includes surface runoff and interflow. So, even though surface runoff stop contributing, but still we have got direct runoff in the form of prompt interflow. The direct runoff stops at point A, end of direct runoff. That means interflow also stops, end of direct runoff. Okay? Point of rise means this is a first drop, beginning of direct runoff. So, direct runoff joins first at point A, that is surface runoff. So, end of direct runoff is at point E. Then if you see this horizontal axis, so from the point of A, joining of the direct runoff to end of the direct runoff, that time interval is called base time, TB. We call it as TB or TL, TB or TB, base time or time base. Okay. It's called TB. And this one is called D. Rain has occurred only for D hours, but runoff commenced in a catchment for TB hours. So this TB is much greater than D. Okay. That point you have to remember. So direct runoff contribution is for very long period, whereas rainfall contribution is short period. Rains are sporadic in nature. Sporadic means what? They instantly happens in a catchment and disappear. Rain just happen, disappear, but runoff continue for long period, 24 hours, 48 hours, 72 hours sometimes, something like that. So the D is called capital D. B and D, no? This is, I took capital D, yeah? Okay. This is, I'll take small letters with this. Okay. Because capital D I used for, okay, capital T I'll take, otherwise what is it? Duration of storm, I'll take it as capital T. Okay, can you keep it, capital D, no issue. So this T is known as storm duration. How long rain has occurred? Normally you express in hours. And TB is known as base time. How long direct runoff is contributed, or time base. How long direct runoff is contributed to the river from a catchment. How long catchment drain direct runoff into river. That's called base time. First drop of direct runoff to last drop of direct runoff. First drop of direct runoff joins at point A, last drop of direct runoff ends at point E. So end, starting of direct runoff and end of direct runoff. Okay, that is TB. Then from center of storm to peak of hydrograph is called lag time. Center of storm to peak of hydrograph. This is called time lag, TL or TP. Lag time, we call it as lag time. Okay. From the end of storm to the end of direct, that end of surface runoff, direct surface runoff is called time of concentration. From the end of storm to end of surface runoff. That means this time. From year to year. This time is called time of concentration. These questions and all, they are asked in GATE exam. Diagram is given typically, and you have been asked to identify what is time, where is time of concentration. In terms of numbers are given, hours. So nothing but this is time of concentration. So time of concentration means what? Time taken by the runoff to deliver from the farthest point in a catchment to the catchment, the where exactly this runoff is measured. So from here, time, this is the farthest point in a catchment. Time taken by the runoff to join this point from here to here. The total time taken by the runoff is called time of concentration. Okay. This TC is known as time of concentration. And one more we discussed there. What is that? TL, lag time. Time lag. Okay. So this many components are there in a hydrograph. So they'll ask questions from this as well. Understood now? Some people denote it as TP or TL also. Okay, no issue. Next, the very important component of this is, actually we appreciate only the fast delivered runoff. We can't wait so long period in collecting the water from a catchment. We appreciate only that part of runoff which is fast delivered into river. So direct runoff. So to work out direct runoff, but unfortunately storm hydrograph or flood hydrograph or total runoff hydrograph, this consists both direct runoff and as well as base flow. But base flow we don't appreciate. It takes so long time, we can't wait so long period. Therefore, we separate base flow from direct runoff. Base flow is separated from direct runoff to obtain direct runoff from a catchment. By separating base flow from storm hydrograph or flood hydrograph, direct runoff delivered by the catchment is estimated. Direct runoff or delivered from the catchment is estimated. Okay, how to separate base flow? There are so many methods are there, but base flow is a known component in our all analysis. Therefore, separation of base flow, all those methods are not required. So base flow is a known component. They will give you for 1 mark, 2 marks question, you can't explain because the theory question graphically you have to separate. I will explain you a simple method, straight line method of separation. In straight line method of separation, what we do is, are you following or just blindly? This is storm hydrograph or flood hydrograph. Okay. So this is one method, simple method among all. So from the peak of the hydrograph, from the peak point of hydrograph, first drop of direct runoff when it is delivered at point A, that is known to you, physically you can notice it. The last drop of direct runoff when it is stopped delivering, that is difficult to find out. Therefore, to find it out, what we do is, from the peak of the hydrograph for a length n hours, so we draw one horizontal line. That horizontal line, from there we drop on vertical. That vertical cut the recession limb at point E. So where exactly this vertical cut recession limb is taken as point E. Point E is end of direct runoff, point A is beginning of direct runoff. If you join both of these points by a straight line, then that straight line separates base flow from the direct runoff. So this is called straight line method of separation. So this part of runoff is called base flow then. This portion of runoff is called base flow. This part of runoff. And the top portion of is called direct runoff. Direct runoff. This is the topmost portion. It contains direct runoff contribution. So this n value, how to find out? This n value we arrive at in terms of so and so hours, because this is a q versus time axis. Time in hours, q is meter cube per second. So this 0.83 into n is a function of catchment area. Then empirical formula, where A is equal to catchment area in kilometer square. If you substitute that n value into this, right, we'll get so and so. We'll get in days first, then you can convert into hours. N days time. Days will get straight away. Then you can convert this value into hours by substituting catchment area in kilometer square. Okay? So assume that base flow is given to you. Mostly they will give you. You are not expected to separate base flow graphically by like this. So there are half dozen methods are there how to separate base flow. But that and all not required, because graphical questions no way they will ask in exam. So base flow. So once you separate base flow from the total runoff hydrograph, the whatever hydrograph that we obtain is called direct runoff hydrograph. We call them as DRH. What do you call? Shortcut DRH, direct runoff hydrograph. So direct runoff hydrograph is equal to, it is storm hydrograph minus base flow, or flood hydrograph minus base flow. After separating the base flow, the hydrograph obtained is known as direct runoff hydrograph. After separating the base flow, the hydrograph obtained is known as direct runoff hydrograph. So how to find out direct runoff hydrograph? Right? You have got, will be given one storm hydrograph. That storm hydrograph is known to you. Of course, this is known to you. So from this we separate base flow. Let us assume this base flow component is this base flow. Then there is a remaining hydrograph. The whatever hydrograph that is there on the top, that represent direct runoff hydrograph. This total is storm hydrograph only. So we separate base flow. This portion is base flow. The remaining hydrograph obtained is called, after separating the base flow, this part of hydrograph, only this portion you take, then that is called direct runoff hydrograph. So how to distinguish the storm hydrograph from direct runoff hydrograph? So direct runoff hydrographs always start with 0, end with 0. Storm hydrograph always start with some value, end with some value. You start with base flow, end with base flow. But whereas this direct runoff hydrograph start with 0, end with 0. That's how we have to differentiate between direct runoff hydrograph and storm hydrograph. Understood now? Or am I confusing you? Am I confusing you? No? Then how you can use this direct runoff hydrograph to estimate runoff component? Let us see. Arjun Singh Panwar, I'll try to take, I don't know my schedule. So estimation of direct runoff hydrograph. So our object is what? Finding direct runoff only. Using direct runoff hydrograph. Once you arrive at direct runoff hydrograph, then you can find out runoff resulting from a storm. Okay? This is direct runoff hydrograph. Keyword says time plot. So start with 0, end with 0. This is direct runoff hydrograph. So if we take any ordinate of direct runoff hydrograph at any point of time, right, this ordinate if multiply with time, what will get? Volume of runoff. So volume of runoff at time t is equal to volume of runoff delivered by catchment into stream at time t. At time interval t, at any time interval t, t is equal to qt into t. What is qt? Ordinate of direct runoff hydrograph at a time t. So you want to measure total volume of runoff from a catchment, what you need to do? You have to measure total area of hydrograph. So total volume of runoff from a catchment is equal to total volume of runoff delivered by a catchment into stream. What is runoff? Direct runoff only by default. Because base flow we ignore. Base flow being so small, most of the times it is neglected. So base flow is so small, so most of the times it is neglected compared to direct runoff. So volume of runoff means direct runoff is equal to, it is area under direct runoff hydrograph. We measure total area under direct runoff hydrograph, then you will get total volume of runoff. Total area under direct runoff hydrograph or total area of direct runoff hydrograph. So it is a non-linear curve, so finding area is not that easy. Therefore what they do in exam is, they assume that direct runoff hydrograph is in the form of a triangle. Direct runoff hydrograph is in the form of a trapezoidal, something like that. So therefore easily you can measure area under direct runoff hydrograph, area of direct runoff hydrograph. So once you get volume, so then you can get depth of runoff. Runoff is expressed in terms of depth only. Whenever we talk about runoff, by default it is direct runoff only. Depth of runoff R is equal to, it is total volume of runoff delivered from the catchment by catchment area. So we are collecting all this runoff from a catchment of certain area. So total volume of runoff by catchment area will give depth of runoff. Okay? So depth of runoff, that's how we can estimate runoff component from a catchment. But most of the times it is non-linear in nature. Therefore, to make your life simple and easy in exam, what they do is, direct runoff hydrograph is in the form of a triangle. Direct runoff hydrograph is in the form of a trapezoidal, something like that. Note, direct runoff hydrographs are non-linear. Non-linear in nature. Therefore, measuring area under curve is difficult. Note 1 this is. And base flow is so small compared to direct runoff, therefore most of the times it is neglected. Base flow runoff is neglected. Base flow is so small amount compared to direct runoff component. Therefore it is neglected. That is note 2. Most of the times we neglect base flow. And third thing that we need to know is note 3. Note 1, note 2, note 3. Direct runoff hydrographs are assumed as linear for our comfort and convenience to measure area under them. So if direct runoff hydrograph is something like a triangle, they will give you like this. Actually it is not a triangle, it is idealized as a triangle. Okay? So little error would be there, that's fine, it's okay. It is not a big error. Suppose you have got a hydrograph like this. Okay? You have got a skew type hydrograph. Skew type hydrograph, squatty type hydrograph, two types of are there. Sharp peak is there. Then it is idealized as triangle. Right? Something like this. Similarly, if you have a squatty type hydrograph, that is base more, peak has wide peak, like this. Right? Such type of hydrographs we can idealize as trapezoidal shape. We assume it as trapezoidal in, so that we can easily measure areas. Okay? So this is assumed as triangle, this kind of things. So that area under curve comfortably you can measure. This is assumed as trapezoidal. Therefore, area under curve comfortably you can measure. For our comfort and convenience only. Actually, they are not trapezoidal, they are not triangle, because non-linear shaped curves difficult to measure their areas. Therefore, for our comfort and convenience, we presume them as, we take this as triangular shaped hydrograph, this as trapezoidal shaped hydrograph, something like this. Idealized. So therefore we can measure area under the curve. So this is reduced into this one, this is reduced into this one. So therefore we can comfortably, then it has got TB. Same TB, here also same TB. This is TB base time. This also got TB base time. Same TB it is also. So this has got a peak QP, same QP will take. Small error would be there, but okay it is. Idealized, you get small amount of error. So here two TBs will be there. TB2, the top is given as TB1. And only one peak, this is peak. Then easily you can measure area under the curve. Understood? Clear or not? If it is clear, then we'll see how this can help us in working out area under the curve. For triangular shaped direct runoff hydrographs, so volume of runoff is equal to area under direct runoff hydrograph, which is equal to half into QP into TB. Half BH triangular area under curve, right, is idealized. Actually is this one only. So this is treated as like this. Trapezoidal shaped direct runoff hydrograph. For trapezoidal shaped direct runoff hydrograph, okay, volume of runoff is equal to, runoff means by default it is direct runoff only. So area under direct runoff hydrograph or area of direct runoff hydrograph, it is A plus B by 2. So TB1 plus TB2 by 2, A plus B by 2 into H. Peak is QP into QP, that will give area under curve. Okay. So for non-linearly shaped hydrographs, so they will give you ordinates. For non-linearly shaped hydrograph, so ordinates will be given to you like this. Whenever ordinates are given means, but by default we assume that it is non-linear in shape. Doesn't mean that always correct. Even linearly shaped hydrograph also have got ordinates. But generally linearly shaped hydrographs we don't need ordinates. We just need only peak ordinate. For non-linearly shaped hydrographs, all ordinates are required. So their ordinates are, let us assume, this is 0, QP1, QP2, something like that. These are the ordinates. Okay? Or OD, ordinate of direct runoff hydrograph. At 0 time interval is OD0. At T1 time interval, OD1. So at T2 time interval, OD2 up to ODN. ODN also happen to be 0. OD0 also 0, ODN also 0. At time Tn. Like this, ordinates will be given to you at different time intervals. So when these ordinates are given, then by using trapezoidal formula, we can find out total volume of runoff. So by using trapezoidal formula. Simpson's formula, trapezoidal formula and all you learned in surveying, isn't it? Area under direct runoff hydrograph is measured in case of non-linearly shaped hydrographs. So what is that trapezoidal rule? So volume of runoff is equal to it is delta T into first ordinate plus last ordinate, discharge ordinates only, by 2. First ordinate also 0, last ordinate also 0. 0 plus 0 by 2 plus sum of the remaining ordinates, sigma of remaining ordinates. So this will give volume of runoff. First ordinate and last ordinate always 0. Remaining ordinates you sum up and multiply with the delta T. Delta T is time interval between the ordinates. Between these two time intervals, delta T. Between T1 to T2, T2 to T3, these are called delta T. Time interval between the ordinates. Time interval between discharge ordinates. That's how we can find out. So volume of runoff you can work out by using trapezoidal formula. Okay? So I have given enough amount of information to work out runoff resulting from a catchment by using hydrographs. Let us work out few numericals before we close this topic. More numericals will work out tomorrow's class. But let us start with the simple numericals. Then we will try to solve tough numericals also. Shall we proceed with numericals? So example 1. This question has been asked in ESE exam. A direct runoff hydrograph due to isolated storm was triangular in shape. This for our comfort and convenient only, they are assuming it as triangular. Truly speaking, they are not triangular, they are non-linear only. To make things simple and easy for our comfort and convenient, this assumption they made in shape with a base of, base means what? Time base, 80 hours, and a peak of, peak means what? Peak coordinate, 200 meter cube per second. Okay? If the catchment area is 1440 kilometers square, the effective rainfall of the storm is options are given. One is 20 centimeter, B 10 centimeter, C 5 centimeter, and D 2 centimeter. ESE 2010 question this is. Come on, work out. Let me see how many of you work out. So what he has given is a triangular in shape. Triangular in shape with a base of 80 hours, time base, with a peak coordinate of 200 meter cube per second. This is direct runoff hydrograph. What I have been asked to find out? Effective rainfall. Effective rainfall means what? Runoff only, direct runoff only. Effective rainfall means runoff. And what we need to do? Triangular shaped hydrographs. We will work out volume of runoff. Volume of runoff is equal to area of direct runoff hydrograph. It's equal to triangular half into B into H. So this is in meter cube per second. This also convert into seconds. They cancel out. We will get answer in seconds. But it is given in hours. To convert hours into seconds, what I do? We will multiply with 60 into 60. So this is also in seconds. So second get cancelled, left answer in meter cube. That is volume of runoff. Catchment area is given as 1440 kilometers square. That you can convert into meters square. (1440) kilometers square is equal to how many meters square? Into 10 power 6. 1 kilometer is equal to 1000 meters. Kilometer square means kilometer into kilometer. 1000 into 1000. 10 power 6 meters square. So this is in meter cube, this is in meter square. Can't you work out runoff? Runoff means by default you express runoff in terms of depth only. So therefore depth of runoff is equal to, or simply runoff. Runoff is always expressed in terms of depth. Is equal to is volume of runoff by catchment area. It is collected from catchment. So volume of runoff we got half into 200 into 80 into 60 into 60. IS people, they are supposed to work out this question without calculator. That way simple numerical values are given to you. For you calculator is allowed. Therefore tough numericals they will ask. 1440 into 10 power 6. So this is in meter cube by meter square. You will get answer in meters. Then you can convert whichever unit system you like. Meters also you can convert. Come on, work out. So let me work out. So without calculator also you can manage. Not a difficult thing it is. Okay. 100 this is. 100 into 80 into 60 into 60. So 12 1 ja. 12 2 ja. 120 this is. 12 5 ja. So somehow we can manage. Anyway, for us is GATE exam. Calculator is allowed. Let us assuming that calculator is allowed in the exam. 100 into 80 into, I am using calculator, 60 into 60 by 1440 into 10 power 6. So it is 0.02 meters. I got 0.02 meters, but answer is given in which unit system? Centimeters. So how to convert meters into centimeters? Multiply with 100. Then this become centimeters. 20 centimeters. 1 meter is equal to 100 centimeter is equal to 1 meter. Therefore to convert meters into centimeters, multiply with 100. Mm means 1000. So now verify with the answers given options. 20 centimeters is there or not? Exactly. This is the answer for that question. Try one more question before we wind up. This is a GATE question. This is GATE 99. So what is given? A direct runoff hydrograph due to an isolated storm. With an effective rainfall of 2 centimeter was trapezoidal in shape as shown in figure. the hydrograph corresponding to catchment is, the hydrograph corresponding to catchment area in square kilometers of, options are given. Option A is 790.2. Option B is 599.4. Option C is 689.5. Option D is 435.3. So he has given the shape of hydrograph also, the trapezoidal in shape. This is 90 hours, 70 hours. The time axis, no, this is, and this is 4 hours, and peak is given as 90 meter cube per second. Come on now, let us work out. This is direct runoff hydrograph. So what have been asked to find out? Catchment area. How to find out catchment area? Volume of runoff by depth of runoff. Effective rainfall is given to you. What is effective rainfall means? Runoff only. So in this question, last question, runoff is unknown, catchment area is given. But in this question, runoff is known, you have to work out catchment area, exactly opposite. 2 centimeters means 2 by 100 meters. Okay? So area of catchment you have to find out. What is catchment area representing this hydrograph? That is unknown. So what is volume of runoff? Volume of runoff is equal to area of direct runoff hydrograph only. Area of direct runoff hydrograph trapezoidal in shape, A plus B by 2 into H. Height is 90 cubic meter per second. This is in hours, this in meter cube per second. To convert this also in hours, so you can multiply with this into 60 into 60. Then it becomes meter cube. Okay? So therefore catchment area is equal to, so it is volume of runoff by depth of runoff. Volume of runoff already we got 4 plus 70 by 2 into 90 into 60 into 60. Depth of runoff is 2 by 100. So this meter cube by meter, you will get answer in meter square. To convert this straight away in kilometer square, what to do? You have to divide by 10 power 6. So catchment area A in kilometer square is equal to in square kilometers. You have been asked to find out. Therefore, it is 70 plus 4 by 2 into 90 into 60 into 60 by 2 by 100. This in meter square. To convert meter square into kilometer square, we divide by 10 power 6. Then we will get answer in straight away kilometer square. Come on, work out. Answer in kilometer square, 74 by 2 into 90 into 60 into 60 by 2 into 100. Divided by 10 power 6. So 599.4. I got exactly 599.4 kilometers square. That was the answer for this question. So this is how we work out numericals related to this. 599.4 is there? No, given options. This is B is the correct option. Okay then, today I'll stop here. Tomorrow we'll meet again. tomorrow possibly, tomorrow I'll be taking class tomorrow 12th January, no? 4:30 to 6 I'll take class. Tomorrow I'll take class from 4:30 to 6. We'll see more numericals and hydrographs. Hydrograph continues. Hydrograph is a big topic, so it takes time. From here only you'll get so many number of questions from hydrographs and infiltration. These two topics are very, very important in hydrology. So that's all for today. Anyway, from tomorrow onwards, Unacademy offering big discounts, so you can enroll in the discount program. So I'll show you what discounts they're offering. There's a discount they're offering from tomorrow onwards. Already it is offered, no? This is discount program. So this ends tomorrow, January 13th. Use code GATE Civil. I think it is value for money. Okay then.